Okay, so welcome to our lecture for today. So we're going to discuss the zoning for rainfall-induced landslide. As for our learning objectives, we have first, recall concepts on various grades of zonation, and then describe the procedures on grade 1, grade 2, and grade 3 levels of zonation. Then describe grade 2 procedure that will be introduced to this lecture. And then we're going to use that procedure and assess landslide susceptibility using the introduced procedure by and by. So as we can recall, we have the term zoning, meaning it is just a matter of mapping the landslide prone areas. Okay, there are red sections that is highly susceptible, or there are portions that we need a few attention to it. So it was categorized into 3. So this is according to the requirement of the data precision and levels of credibility of output. So for grade 1, we have geomorphological method. So when we say geomorphology, it refers to the physical attribute of the slope. So the required information for that is topographical maps, geological maps, geomorphological maps, and the aerial photographs. So we can find that many in established maps by the Mines and Geosciences Bureau in our country. Okay, so for the grade 2 level, so this is a type of a method wherein we use overall score evaluating method. So the required information, topographical maps, geological maps, vegetation, and land use maps. So in here, we are getting closer to a more rigorous survey, but this method is actually developed by many researchers wherein para ka lang nag-score ng beauty contest. Okay, so we'll just have to use some tools in scoring and a little bit of arithmetic to solve for the factor of safety. Well, the factor of safety is the determining factor in terms of the susceptibility of the landslide. So the grade 3 level is the rigorous method. So this is the geotechnical method, which requires subsurface and in situ test. Okay, so we have more extensive details and testing that will be conducted on this grade 3 zoning. So the required information, so aside from the topographical map, we have soil boring data as well as rainfall data. So this is actually the practical application of the theoretical concepts brought into actual field conditions. So our assessment will be supported by concrete evidence and real data or in situ data. Now moving on to grade 1 methods. This is the geomorphological method. So the attributes are on physical. Okay, so when we say physical, the shape, the angle, the cross section, and etc. So failure most often occur in zero order valleys. When we say zero order valleys, these are the lower portion of the mountain Okay, so we can see here on the topographic map, yung zero order yung pinakamababa. And then next to that is the first order, and then the second order valley. Okay, so normally the failure occurs on the nick point of this zero order valley. So the criteria here on the grade 1 method is a zero order valleys are more susceptible to erosion and landslide. Secondly, heavy rain type occurs below the convex breaks of a slope, which corresponds to a high occurrence zone. We can see here a cross section that we have the riverbed, and on the riverbed there is a transition between the concave and the convex curves. So ito, concave curve yan. So there will be a reversal on the curve here, and on that reversal we will have a convex zone. Okay, so the transition, the location of the transition is actually the most collapsible zones on that section. So if we have that two criteria, we are in grade 1 method. So for grade 2 method, this is the overall score evaluation method. So the practical methods for risk evaluation are based on the landforms, geological conditions, present protection measures. So there are a lot of research products that has or that developed overall score evaluation method or grade 2 methods. So we have here a sample procedures by the Ministry of Construction. As we can see here, we have a checklist of the geomorphological condition, the presence of spring, and then the failures around the area. So the technical standard of protection measures, abnormality in protection measures. We'll just have to select and observe those parameters and select the scores. So the score will be categorized into two. We have the natural slope or artificially modified slopes. So this is the risk ranking, wherein if we have a score for natural slope greater than 9 or for artificial slope greater than 15, the risk ranking is actually very high, and that is ranked A. And then for the second rank, we have the range 6 to 8 for natural slopes, 9 to 14 for artificial slopes, and that will be having a risk ranking of high. And then for letter C, if the score is less than or equal to 5 for natural slopes or for artificial slopes of less than or equal to 8, that is a ranking that equates to moderate. And then this is actually the flow chart of the scoring method introduced by the Ministry of Construction. So it came from the investigation of the slope. Of course, we're going to use the checklist, and then we score, and then we rank the danger, and that will be the basis to prioritize measures for slope protection, because we could not address all of the slope. Yun nga, sabi mo matarik, pero hindi naman pala masyadong delikado. So the basis is the ranking of danger. Okay? So this is actually the tool, the actual tool or the field investigation card, wherein there are figures, the slope form, cross-sectional forms, and then the nick point, the surface condition, the thickness of surface soil, geological condition, the crack spacing, relationship between slope, inclination, fault, spring water, age of trees, existence of root, slope failure in terms of age, position in the slope, condition of the countermeasures, condition of upper slope of countermeasures, landslide, land use, okay? Land use, number of residents, public building, number of residents at the foot of the slope. So those are the information so that you can appropriately score and refer to the table here. Okay, this one. It is ranking. And then another method proposed by Mora and Varson. We have here a checklist for the lithology. So lithology, what is the slope material? Okay, so as example, we have here a high degree of weathering above mentioned lithologies and of hard massive plastic sedimentary rocks, low shear strength shearable fracture. So that is a moderate. Okay, so it will be scored 2 for parameter S1. Okay. We have here the relative relief values and their classes of influence in landslide susceptibility. So relative relief 0 to 75 meter per kilometer squared. The susceptibility is very low, so 76 to 175 low, and then the greatest is greater than 800, that is very high. And then we have here the classes of average monthly precipitation. So this refers to the precipitation data, the average monthly precipitation. If we have less than 125 and greater than 250, as well as this range, we have the following assigned value. And also it considers the weight for annual precipitation. So the summation of precipitation averages, we have the following susceptibility ranking. And of course the influence of the seismic intensity. So this is modified Mercalli scale. So we have the seismic that will be a triggering factor for landslide generation. So this is parameter TS. So from that we can finally compute by a simple arithmetic the landslide hazard index. Okay, so from the value of HT, or the landslide hazard index, we can see a table to categorize the susceptibility level of the certain slope. So we have negligible, low, moderate, medium, high, and very high. So this is the procedure that is introduced by Mora and Varson. And when we have that, we have the grade 2 methods, or the overall score evaluation method. Now, moving on to the geotechnical methods. We have here the detailed survey. So of course the purpose of this one is identification of slopes with high failure risk. More specific identification than the preliminary survey. Then the evaluation of type, depth, and magnitude of failure. Evaluation of geological and geomorphological conditions of the base layer beneath the slope failure zone. And then the evaluation of distribution and continuity of the open cracks in rock mass. Then the stability analysis for individual slopes. So we have actually a traditional existing slope stability analysis by finite element method, or FEM, or it could be LEM, or the limit equilibrium method. So basically, there are a lot of software that has the slope stability analysis. So evaluation of countermeasures. So this will be more on the engineering intervention based on the slope stability analysis. Of course, when we design a slope protection or slope mitigation measures, we need to understand the soil structure interaction, or the interface between the soil and whatever structure we intend to put up to counter the failure of the slope. So the detailed survey are the following. We have the topographic survey, the aerial photograph interpretation, geomorphological survey, surface geology survey, borehole survey. So the borehole survey will have a lot of data that will be acquired through borehole, like groundwater table, the pore water pressure, as well as the stratigraphy of the soil. Then we have the seismic exploration, the rock test, and the groundwater survey. So from that, we can evaluate now the slope instability if we have the relative data from the field. So, of course, the factor of safety shall be calculated. And, of course, the estimation of the outer boundary of the debris flow from slope failures. And if we have that, we have the grade 3 method, or what we call the geotechnical methods. So I would like to introduce to you the project or the research output of Dr. Daniel Pickley as a balik scientist in KSC, now KSU. So this research project is actually a grade 2 method that was developed for communities and non-experts. So when we say non-experts, they do not have technical knowledge on landslide assessment. So this procedure is a simplified version of the complexity of landslide susceptibility assessment. Okay, so it was developed last 2009. So the title is a simple and site-specific procedure for conducting rain-induced landslide susceptibility assessment. So the main objective is the development of site-specific but simple graphical hazard assessment procedure for rain-induced shallow depth. So when we say shallow depth, it could be translational or rotational type of failure. So iba yung shallow depth dun sa deep-seated landslide. Okay? So the output of the research actually surveyed around 243 sites and eminent landslide sites. So it was originally planned with 60 sites only, but extended to 243 landslides. So imagine that extension of the sites, because there are lots of landslide occurrences during that time, especially during heavy rain. So several conferences and workshops out of this developed product were also presented. So KSC with the LGUs in Kalinga and other CAR SUCs. And then the Earthquake Exposure and Vulnerability Workshop by the PhilVox and Geoscience Australia last November 14, 2009. And then the PICE Convention in Baguio City. Then the second regional conference on geodisaster mitigation in ASEAN. This is in Bali, Indonesia. So those are several conferences and workshops in which the procedure was presented. So the project leader is actually the Balik scientist, Dr. Daniel Bickley. So moving on to the concept. So it takes off from the theoretical concepts of the factor of safety. So here we can see a simple illustration wherein the factor of safety is the capacity of all over the loading. So it cannot be that the loading could be greater than that of the capacity. So we can see here in the first illustration, a bridge capacity or strength with 30 tons will have a factor of safety of 1.2 if the weight of the truck or load is only 25 tons. However, if this 25 tons exceeds the capacity of 30, the factor of safety will no longer be feasible and implied of danger. Okay. So from that, the basic factor of safety in here is actually the S rating all over the alpha rating. And S rating refers here to the slope material. So the S rating is the capacity of the material. So when we have a dense soil, a dense intact soil, that implies a higher strength, okay, a higher resistance. And with the alpha rating refers to the slope angle. Of course, if we have steeper angle, the component of weight will increase and will be a driving force towards collapse. So here's the illustration. So as an example, for slope rating with which includes slope material with tension cracks in it and a steeper slope angle, say 32 degrees, and if we have a scoring on that, basically it will have a lower value for factor of safety. Remember that the safest factor of safety or the minimum factor of safety should be equal to 1. A value that is less than 1, of course, it fosters danger to the slope. Okay, so this is the concept or the theoretical concept that will be the basis of the study. So referring to the S rating is actually the strength parameters of our slope material. So for soils, we say that soils are granular materials. We have the coarse material or the rough material. We have the sand and gravel. And if we have a fine material, we have a clay or silt. So the physical parameters or the mechanical parameters. So when we say strength parameters, we are referring to the mechanical parameters. In soil, we have the angle of friction, okay, and the cohesion. So the angle of friction when we dump a soil, okay, pag hinulog natin yung soil, the angle that will be formed out of this stockpile is the angle of friction. So this is in a dry condition, of course. So angle of friction is the internal intact strength, and alpha here is the angle of slope, wherein the maximum angle that this material could withstand. So S rating for soils were quite easy to establish. Significant amount of data on phi. So phi is the angle of friction and cohesion of soils. So in laboratory tests, we can obtain this by direct shear method. So iba naman yung parameters sa rock. For rocks, mass strength is primarily characterized by the cracks and discontinuities present in the rock mass and its intact rock strength. So meron din tayong tinatawag na intact rock strength or GSI. This GSI is Geologic Strength Index. Meron din tayong tinatawag na disturbance factor, RQD, rock quality, and then yun, ito, GSI, intact strength, disturbance factor. So this is equivalent to angles of friction and cohesion in soils. So with this, your slope material could either be rock or soil. So rock can be categorized into hard rock and soft rock. So in a while, I'll just present that one, the difference between hard rock and soft rock. So when we say soft rock, it is subjected to decaying or weathering because of a lot of factors that we have already discussed. So yung scoring that was developed on this is S rating, yung slope material. So this is scoring for rock. So na-categorize na lahat ng mga klase. So yung pinakamataas is HR1 or hard rock 1. It is massive and intact hard rock wherein S is greater than 2 meters. So yung ano tong S? S is the spacing ng mga discontinuities ng rock. Okay? Kung may nakita kang crack, tapos may crack sa taas or adjacent to that crack, and if the spacing is greater than 2 meters, hindi masyado yung crack. So meaning, we will be having a score of 100 for that. So remember that the more S rating, the more higher is the factor of safety, because yung S rating, nasa numerator siya ng factor of safety. And then we also have the HR2 blocky or well-interlocked hard rock. So the spacing is between 0.6 up to 2 meters. So yung score niya, 45. So bumaba na siya ng 45. So you can see the difference. And the difference, biglang nag-drop yung score, meaning hindi na maganda kapag dumami na yung crack sa hard rocks. And then we also have hard rock 3. This is the highly fractured, wherein the spacing, yung spacing very close na, no? From 4 inches to 0.1 meter to 2 feet. Okay? So, very close. Kitang-kita mo na uh, highly fractured yung rock. And the scores, of course, half na ng 45. So, nag-drop na siya sa 25. Okay? Nevertheless, you can see here that hard rock, yung pinakamababa is 25. Still, greater than that of HR4 and fractured soft rock. So, medyo mababa na yung value na score na yun. So, HR4, hard rock 4 is disintegrated. Protruding rocks and boulders may include soft rock fragments. So, ito na yung natanggal, or there is a separation of the material from the slope. Kasi nga, na-disintegrate na, protruding, may mga lumalabas na rock. So, kulang na lang, mahulog na. Kunti na lang, mahulog na. And the score is 13 for that. Okay. So, for soft rocks, it is delegated as SR, soft rock. So, soft rock 1, if we have a massive and intact soft rock, we have 30 score. And SR2, that is a fractured soft rock, we have a score of 15. So moving on to the soil as a material, we have also an established S rating for this. Yung HS1 or hard stiff soil 1, we have the stiff, dense, gravelly, sandy, silty, and clayey soils. We have that rating to be equal to 25. Okay. So when we have a gravelly soil, we have score of 10, and if we have a sandy soils, we have a score of 8, and if we have a silty or clayey soils, we have a score of 5. And then for the alpha rating, we have the slope angle. By the way, sa slope, baka tanungin nyo, paano kaya pag there will be a combination of hard rock and soft rock? So the evaluation here could be could have variation on the result of the factor of safety. So kung ganon, you just have to divide the level of the slope. So kung sa lower portion is having a slope material of hard rock, then the slope stability will be on that portion. And then for the upper part, if we have another type of soil material like soft rock, there will be another scoring for that portion. So what is important here is the predominant material in the slope. So walang perfect na homogeneous material in a slope. So there are a lot of combination between the slope material. So what you do is, ano bang mas marami? Ano bang mas predominant dun sa slope na yun? Although combination siya ng rock tsaka soil, kung mas marami yung rock, then the predominant material will prevail in your scoring. Okay, for the slope angle, we have the following scores. So if we have a steep slope, of course, that will be subjected to high score because, as I have said, the component of the weight will be larger if we have a steeper slope. So take note that this is the alpha rating. So from that, we can now calculate the factor of safety basic, wherein the only consideration is the slope angle and the material. So this susceptibility assessment will be extended to a consideration on some other parameters like the vegetation factor, the frequency factor. The frequency factor is the occurrence of the sign or signs of failure. So as you can see here in the expression, it is being multiplied to the numerator, okay? Because a vegetation also contributes to the stability of the slope. And if your material were subjected to a lot of failure, of course, that will be also a factor to consider. So this is a direct multiplication to the S rating. And then from the S rating, the saturation will have a direct decrease on the strength rate of the S rating. Okay? So kung merong spring yan, mababasa yung material. So the result is that it will be decreased to a certain level. And then the condition of the drainage is very essential in maintaining the strength of your material. Of course, if you divert the water, it will control the infiltration to the slope material. Okay, so that will be directly deducted to the S rating. First, we have the presence of drainage and of course the spring. And then the land use will be a factor to be found in the denominator of that expression. So it will be multiplied to the alpha rating or the angle. So of course land use factor matters. If we have a heavy surcharge on the top slope, of course that will be an additional gravity or surcharge to the slope. Okay. So let us see here some diagram referring to the slope materials that was enumerated a while ago. So we have here HR3, highly fractured and disturbed rock. So it is a hard rock. So sabi natin, this method should be a simple one so that yung ordinary na tao can interpret. So sa manual, meron siyang illustration. So aside from the illustration, you can determine a hard rock or soft rock by a common wire nail that is 4 inches. So yung common wire nail, if you are going to dip that into the slope material, okay, so if you attempt to draw a nail on the slope material, a soft rock will be penetrated by a 4 inches common wire nail. So yung common wire nail, ito yung ordinary na pako. So it is not a concrete nail, but it is a common wire nail that is 4 inches. If you drive a nail on that slope surface, kapag pumasok yan, that is a soft rock. So kapag drive mo naman yan sa hard rock, it will only bounce and matatalo yung strength ng common wire nail. So that is one simple assessment to identify whether your material is a soft rock or hard rock. And then the size of blocks mostly between 4 inches to 2 feet. So the S rating for that is 25. So these are the photos. HR3 it is a highly fractured and disturbed rock. Kaya nga yung size of blocks niya between 4 inches and 2 feet. So medyo malilit yan, meaning very close na yung spacing ng disintegration on the rock. So if you can see, there are also protruding disintegrated material. So that is the characteristics of HR3. And HR2 is a blocky or well interlocked hard rock. Although may cracks siya, the range of the crack or the blocks is in between 2 feet to around 6 feet. So medyo malalaki yung disintegration or the spacing of the crack. So the S rating for that is 45. And then we have here HR1. Okay, so massive and intact. So there are very few widely spaced cracks or discontinuities. So the spacing of cracks is 2 meters apart, and the S rating for that is equal to 100. So here are the photos. This is the massive and intact hard rock. So we have already discussed this, blocky. So these are the photos of the HR2 blocky well interlocked hard rock photos. Usually this is a granodioritic or volcanic rock. And then highly fractured. And then the disintegrated or protruding rocks. So this is the lowest among the hard rocks or the HR4. So yan. There are already separation on the slope. And then SR1 is the massive and intact soft rock. So soft rock can be penetrated by a 4 inches common wire nail with hammer. So it is weaker than concrete, or it is less than 21 megapascal or 3 KSI. So but a fist size will not crumble or deform with hand pressure. So kung kukuha ka ng sample, a fist size sample, if you're going to attempt it to i-crush mo yon using your bare hand, it will not crumble. Ito naman yung distinction between rock and soil. No? So yung soft rock, it will not crumble. Okay? Ngayon, yung ganun din sa massive and intact soft rock, so ano nga siya, very dense siya, you cannot really crumble it by your hand pressure. And then massive and intact, few widely spaced cracks or discontinuities equal or greater than 2 meters apart. So no predominant discontinuity. So the S rating for that is 30. So again, SR1 yung pinakamataas sa soft rock. Number 1, nape-penetrate siya ng 4 inches na pako. Number 2, if you're going to have a fist size sample, it will not crumble by hand pressure. So these are the photos. So doon nag-penetrate yung pako dyan. Certainly, pag kumuha ka ng sample niyan, hindi basta-basta makakrumble if you're going to hand pressure. So you can see here now that the procedure is very simple. By using, by the use of 4 inches wire, common wire, you can already assess the slope material and identify what is the classification, whether it is hard rock or soft rock. And checking the hand pressure, checking the material by hand pressure, you can now distinguish a rock and a soft rock, a hard rock and a soft rock. And then for fractured, soft rock din siya, kaya lang mas ano siya, disintegrated in nature, wherein mas maliliit na yung sizes ng blocks from 4 inches to around 2 feet. So fractured soft sedimentary rock, SR2. And then SR2 for fractured soft rock can be penetrated by pako or common wire nails. Now moving on to the soil mass. So soil mass are classified into 4. It is either HS1, SS1, SS2, or SS3 as flashed in the screen. So yung HS1 is the stiff dense gravelly. Ito yung very stiff, which has the highest S rating, and then followed by gravelly soils, then sandy soils, and the lowest is the silty or clayey soils. So HS1 stiff cemented dense soils. Number 1, it can be penetrated by 4 inches common wire nail by hammer. Now, if we have to check the material by a hand pressure, it will crumble. So between soft rock and dense soils, madidistinguish mo na kasi kapag crinumble or hinand pressure mo yung stiff cemented soil, magka-crumble yan or maburak, no? While on the soft rock, it will not crumble by a hand pressure. So ngayon, kapag if you're going to have a finger pressure naman, it will not deform. Okay? So it will crumble by a hand pressure, but a finger pressure will have no effect on it. No, it will not deform. So no deformation with the finger pressure, but it will crumble with the hand pressure. So more evaluation can be done by the conduct of Swedish weight sounding test. So ito yung NSW. This is the N coefficient that is being used in the Swedish weight sounding test equipment. So later on we will discuss about this one. So these are the sample photos of the stiff soils. So you can see here that some of the stiff soil could withstand a steeper slope. But however, with this kind of material, of course, nakita natin yung score is 25. Masyadong matarik. Medyo vulnerable pa rin yun sa landslide. So for gravelly soils, medyo there is an abrupt decrease on the rating for gravelly soils. So the size of most particles is in between 5 millimeters to 75 millimeters. So yung mga pebble materials are very evident up to sizes of 75 or 3 inches. So fist size sample or smaller containing 5 or more particles will crumble with finger pressure. So if we're going to have a finger pressure on that sample, it will crumble. So this is the indication na ito, ano to, gravelly soils na to. So the S rating is 10. So we have here gravelly soils with photos also. As you can see, obvious na may mga bato yan, of course. May halong sandy deposits. But mas marami yung gravelly, or this is a gravelly soil deposits. For sandy soils, mas mababa siya sa gravelly soils by a 2 point. So the size of most particles is finer. Okay? So maliit siya sa 5 millimeters, and the grains can be distinctly felt by fingers. So sample will crumble with finger pressure. So paano mo malalaman? Kapag hinipo mo yung sandy soils, it is parang liha siya kasi magaspang siya. No? Unlike sa gravelly soil, mafe-feel mo pa rin yung mga size ng pebbles. But in this one, buhangin. Ano? buhangin is something magaspang or rough in nature. So just the same with that of the gravely soils, it will crumble with the finger pressure. So more reliable evaluation again with the Swedish weight sounding test regarding NSW. So we have here a predominant soil deposit with silt and sand deposits here. Okay. So for the last SS3, we have 5. So thumb can indent and will crumble with finger pressure. So kapag finger pressure mo with your thumb yung mismong slope, you can indent. Hindi siya magka-crumple pero magka-crumble. Hindi siya maduduro. Especially when saturated, hindi siya maduduro. Okay. By the way, yung characteristics ng clay, matigas siya kapag dry and napakalambot kapag saturated. So usually by the color and texture, you can distinguish a silt or clay easily. So medyo mas brownish kasi yung clay material. And at the same time, pag kumuha ka ng sample, if you're going to feel the texture, that is somewhat smooth or soapy feeling, no? Madulas. So from that, we can now compute the basic factor of stability. And then, of course, you must have to evaluate also the vegetation, frequency factor, the presence of spring reduction, and then the drainage condition, and then the land use factor. Okay, so these are the scores. For V factor, it is a vegetation cover. F factor is the frequency of failure. S red or reduction due to spring. And then D red is the reduction due to the condition of the drainage or the canal system. And then the land use factor. So i-apply mo lang yung formula ng FS dyan. Then you can get the factor of safety. For the scoring of the V factor, it is categorized with no vegetation. Pag walang vegetation, it will remain. So 1.0 ang factor. And then predominantly grass or vegetation with shallow roots, 1.1. Coconut, bamboo, or vegetation with moderately deep roots, that is 1.3. If we have a dense forest with trees of the same species having less than or equal to 20 years, we have 2.0. Ito, yung pinakamataas is dense and mixed forest with trees having ages of more than 20 years, 2.5. So, basically, in general, vegetation accounts, no? So, occurrence of or frequency of failure. So, if the occurrence is once a year or more than once a year, that is 0.5. So, hindi masyado nagfe-fail yan. So, the presence of failure, ito, yung pinaka frequent pala, no? Once a year or more than once a year, i-reduce nyo yung factor ng 0.5, and then the presence of failure, it will reduce your factor of safety by 30%, or that is multiplied by 0.7. The same true with the presence of tensile cracks, the retaining wall deformation, and if none, mas maganda. So it will also increase to the factor of safety. So meaning, there is no trace of failure. Meaning, intact pa rin yung slope mo. Hence, your factor will be 1.2, or that is a 20% increase on the factor of safety. And then for the reduction on the presence of the spring, here, ito yun. So, sa S rating, may babawas yan. So, kapag merong spring yan, year-long, mababawasan ng 2. Kapag during rainy season, 1. And then if there is no spring, of course, there will be no reduction, or that is 0. And then the condition of the drainage canal system, if there are no found drainage canal system, of course, your S rating will be reduced by 2. So, wala nang drainage. May drainage nga pero hindi naman nagpa-function. So, that is totally clogged, filled with debris. So, it will not function. So, para ding equivalent siya sa no drainage. And then, partially clogged or overflows during heavy rains. So, meaning, hindi na-accommodate lahat ng tubig during heavy rains. It will be scored as 1. And then, water leaks into the slope, 1. And if your canal is in good working condition, of course, your S rating will be maintained. Okay, so as for the land use, we have dense residential area as the highest factor. By the way, it is being multiplied directly into the angle here. Ito kasing nasa taas, ito yung mga resisting forces. Yung nasa baba, that is the driving forces. Remember that alpha rating is a driving force in a sense na yung weight component is the driving force. So, yung L factor naman is the land use. So, ito yung sinasabi ko, additional pressure sa taas. So, tutulungan niya yung weight as a driving force para ihulog niya, or it will facilitate the downward movement. Okay? So, that is why if we have a dense residential area, that is the highest score. So, with closely spaced structure, we have 1.4. Commercial buildings having 2 stories or more, 1.4 din yan. So, residential area, pero hindi naman maraming gaanong bahay. We have 1.25. So, if it is being used as a road or highway with heavy traffic, 1.4. And then road highway with light traffic. So, for the light traffic, we have 1.25. Then the agricultural area, forest, uninhabited or no vegetation, we have 1.0. So, it will remain to be the factor. Okay. So, these are the steps, basic steps. Of course, number 1, prepare and bring the needed tools, materials, take pictures of the site, sketch the side view, top view, and then measure the slope angle, alpha, determine the corresponding alpha rating, identify the predominant slope material or the S rating, compute the basic factor of safety, and then take into account other factors affecting slope stability and compute the final factor of safety. So if we have an assessment that is highly susceptible, of course, that is Fs less than 1, therefore it fosters danger already. So ito na yung range. If Fs is greater than or equal to 1.2, that is stable. And the range of factor of safety from 1 to 1.2, that is marginally stable. And then if we have 0.7 to 1, that is susceptible na, no? And then if Fs is less than 0.7, that is highly susceptible. Actually, these are the sites. Sabi nga natin, umabot sa 243 sites yung na-investigate using this tool. So, with this greater than or equal to 1.2, 5 yung site, walang nag-fail. So, meaning, maganda yung result. Stable nga siya. Okay? And then, for marginally stable, using this tool, yung 7 na survey, walang nag-fail. So, meaning, proven nga to na stable and marginally stable. And then, for this range, 0.7 to 1.0 susceptible. So, 38 surveyed sites, and out of that number we have 27. So 71% ang bumagsak within this range. Okay, 71%. So 27 out of 38. And then for the highly susceptible, wherein factor of safety is less than 0.7, after heavy rain, 7 lang ang naiwan. So meaning 7 lang ang hindi bumagsak. So 95% have failed for these sites evaluated as highly susceptible. So all in all, out of 243 sites, 211 have failed. So percentage of failure, that is 87%. So kapag nag-survey kayo, you must have to bring, of course, camera, measuring tape. Para saan yung measuring tape? You must have to measure the extent of the length of the slope, okay, and then measure the spacing of the discontinuities or cracks. So that is the use of the measuring tape. And then the bond paper, at least 5 pages, pen or pencil, the hammer. Of course, you're going to drive the 4 inches common wire nail to determine your sample or the slope material. And then the shovel or digging material like bareta or pick, and bolo for clearing. So why do we need this one? Of course, you are going to get a fish size sample. Okay. So optional but recommended, we have tilt meter, angle meter, or any device to measure slope angle, GPS receiver device, and then the Swedish weight sounding test equipment, in which later I will discuss to you the procedure on that. So delineation, the survey sites. So assume in this assessment, site has one slope angle and a predominant slope material. Okay? So kung may variation sa slope angle, of course, maaari yung slope mo, isang slope mo, pwedeng maging tatlo yan, tatlong assessment. Upper, middle, and a lower portion. Depende kung hindi uniform yung slope angle as well as the predominant slope material. So if the variation of alpha is within the range of angles for a particular alpha rating, and if the predominant material is practically uniform around the area, then the area can be already identified as one site. Yun, sabi ko nga, otherwise, iba na yung site na yun. So if the slope angle varies and the variation is not within a range of angles for a particular alpha rating, or if the slope material is not uniform around the area of the interest, then subdivide the area of interest into sub-areas with practical widths of around 10 meter or even longer. So you delineate the site now. So when your slide or slope is covered with vegetation, select and clear at least 3 slope material sampling points, each having an area of around 1 square meter, and then sampling points not farther than 20 meters. So if clearing, the predominant slope material is rock, use the reference figures and photographs presented to classify the rock material. Okay. So if soil, dig the areas to a depth of at least around 0.5 meter. Use the reference figures and photographs presented to classify the soil material. So it is recommended that we conduct SWST testing. Okay, so if we need to incorporate the rainfall data, we can replace yung S reduction or the spring reduction and the drainage reduction dito sa S rating. Palitan mo lang siya ng rain factor. Okay, so rain is reduction due to rain depending on the amount of rainfall in 24 hours. So if we have 50 millimeter or less, we have 0. So the range between 2 inches to 4 inches, we have 2. We have 4 inches to 8 inches, we have 3. And more than an 8 inches level or rainfall intensity, that will be scored as 4. Okay, so how can we measure slope angle with a simple folding technique? So you can practice it at home. Ngayon, kapag nag-fold ka ng square paper, i-fold mo yan symmetrically, that is 45 degrees. If you're going to divide this into 3, that is also 30 degrees. And if you have established folding that, the other angle, tapos meron siyang 90 degrees dito, that is 60 degrees. And then, yan, 15 degrees naman with this one. So, you subdivide the 30 degrees, i-fold mo pang isa, no? Isa pang fold sa 30 degrees, magiging 15 degrees na yan. Tapos, mag-establish ka ng 90 degrees dyan. The other angles, 15 degrees, of course, 75 degrees. Okay, so a simple trigonometry, you can facilitate measuring the slope angle by a simple folding technique. So ngayon, paano mo i-measure yung angle? Of course, from this folding technique, dapat meron kang horizontal and vertical folds. Okay, and from that, you will make the horizontal line parallel to the horizontal level of the site also. Practically, you may use the road section kasi horizontal naman yan. And then yun, measure mo na yung angle. Okay? The range of angles. So that's it for this discussion. So it would be very nice if you could use this. So I'll be forwarding this method to you in PDF form so that you can try the tool in assessing the susceptibility of landslide. So part of your assignment, if you have a mountainous terrain in your locality, you can evaluate the site using the introduced method presented. So thank you for listening and have a good day.